how do you succeed at an AI project? In particular, how does a company make a profit from an AI project?
Well, to try to tackle the first question, and I'll run the risk of being a little bit blunt. I think the reason that um, sometimes companies don't get a return on investment is that they don't even try. They don't even kind of recognize that as the goal. Yeah, so sometimes I get a little bit of gentle pushback when I'm hanging out with data scientists on this because I think they want to preserve their ability to explore the data, not entirely knowing where that's going to take them. And I get that. So, sometimes people refer to the 20% time that I think Google popularized. I totally
Mhm.
get that. But when I talk about how projects should always have ROI, I mean, you're officially starting the project. There's a kickoff. There is somebody that's designing the solution. There's probably somebody in a data steward role. There's an internal customer. There's a sponsor. The whole nine yards, right? If you're gonna jump in and you're talking hundreds of thousands of dollars of salary hours and external expense or software expense or what have you. It is crazy to embark on that, right? So I don't want to step on anybody's toes that they shouldn't have a few hours a week where they're just looking for opportunity. I get it. But if you're going to do a real project that's going to take months and cost hundreds of thousands of dollars, if not, break that $1 million barrier, you've got to have some kind of a plan. So I think what happens is that if this exploratory thing gets almost, put into just the long-term thing. That's all the data science team does. Or if the data science team turns into a help desk, that's the other thing that I think is a real killer.
Oh yeah.
Management's just curious about something, right? So I call those insight projects. And sometimes I'll get a funny look when I give a talk on this, and people look at me like, "What's wrong with insight? I thought insight was like the goal." Well, insight doesn't pay the bills because the whole idea of an insight project is the data scientist explores the data. Also, when do you know when exploring is done?
Mhm.
Does exploring take 2 weeks? Does exploring take 10 weeks? Does exploring
Mhm.
take 4 months? You know what I mean? So I struggle with that. So again, I'm cool with this a little bit of time each week where the data scientist is given some freedom to explore a new opportunity. I like that idea actually. But you
Mhm.
get my idea, right? Is that
Yeah.
just poke around in the data and try to find something valuable. When did that process really begin and end? How do you even measure how much money you spent on that, right? But then
Mhm.
the notion is that the deliverable is some kind of a slide deck that gets presented to management. Management goes, "Wow, that's like so cool." They bring that into a C-level meeting or what have you, but it's just this exchange of ideas. It's very hard to measure what's going on.
Right.
So for me, all data mining is what we now call predictive analytics. And even predictive analytics is a little out of fashion. But
Right.
I know some of the authors of CRISTIM, which is the cross industry standard process for data mining. And I've always felt like CRISTIM was a better fit for supervised. And the folks that wrote it said, no, we're trying to cover unsupervised too. I don't know if I've ever been completely sold on that. But the point is, that's all it is. It's making some kind of a prediction. So when I'm sitting down with a client, and this is literally the first hour, I want to know, what are we predicting? And sometimes it's either not clear or there is no prediction. And we can maybe talk about that. But I want to know what we're predicting, what benefit they get, tangible, measurable benefit do they get by knowing that prediction in advance? And then what the heck are they going to do with it once they know, right? So I remember having a long conversation with, it was actually a government gig. So it was about federal funding and it was about project management and so on, right? So they wanted to know, could we predict in advance what projects would um, go over time, over schedule, or over cost? So I said, well, great. If you knew that about a project, it's an 18-month project, big government expensive project. and you knew at the 6-month mark that it was likely to go beyond 18 months,
Mhm.
what action were you going to take? And John, it took 10 minutes to get a straight answer to this question, because it was like, well, what do you mean? I said, you've now learned that this is going to happen a year from now.
Mhm.
How is that measurably valuable to you? Say, well, if they go over, they just get extended. They're important projects. Once they're approved, we have to finish them. But it would be nice to know that it's going to be late. You're not going to accelerate it so it ends on time. You're not going to. There was
De-scope.
no action. And you'd be surprised how many times conversations like that fizzle out. So what I urge clients to do, and this is the first step, I think, in ensuring that this happens, is to have more than one project that's in an analytics portfolio, so that you're constantly vetting them and deciding not only what projects are worth doing, but what projects should be done in the current calendar year. Because what is a data science team supposed to do if this is an extremely top-down process and they're not allowed to kick the tires and question the project? Then the head of the data science team, if they say no to a project, then what they have they then have no current work. What should really happen is there should be 3 or 6 or a dozen projects
Mhm.
that are important to management. And the data
Mhm.
science team should get a chance to kick the tires,
Mhm.
to estimate ROI, and
Mhm.
say, you gave us this half dozen. We recommend, as the data science team, that 4 out of these 6 are a good fit for our team. And these 2 out of the 6 we should do immediately, because they really have the potential for good ROI.
Yeah. As the chief data scientist and the co-founder of a machine learning company called Nebula, I um, I am involved directly in this kind of process so we prioritize projects. So there's dozens of projects that if we had an infinite number of resources, an infinite number of data scientists, if we had dozens of data scientists, then they could each be tackling one of these projects. But we don't have dozens of data scientists. And so I liaise between the executive team and between my data scientists to it's like it's a bit of a chicken and egg, but um, but the end state is clear. So you work with the data scientists to to estimate how much work a project might take. And some projects are relatively discrete, where you can say, there's very few unknowns in being able to deliver that to you. And so, we can estimate that it's about uh, 2 weeks of work full time for one data scientist to be working on, or a month, or whatever. Like many things in computer science, we do our estimates in powers of two. So it's a 1 week project, it's a 2 week project, 4 weeks, eight
No.
weeks, um, and but then there's other kinds of projects that are more like the exploratory ones that you're describing, where we're like, okay, we just got access to dozens of new API endpoints from this new vendor that we're working with. We are pretty sure that some of them are going to be really useful to us, but there's also lots of other ones there that we should look into. And that falls into the bucket of the thing that you're saying. Like, you could explore this forever. Like, what other things could we be doing with our data or blending with our data? So for those kinds of projects, or projects where we want to make we might have some production machine learning model where we're like, oh, transformer architectures, maybe that's something we should be considering for this natural language model that we already have in production. And then it's like this other open-ended task of how, we don't have a transformer model already in production, so there's going to be some time learning which kinds of architectures we might want to work with, getting used to having to use a lot more hardware than we ever did before, and running into roadblocks time and again there. So there end up being these projects where it's difficult to say when you succeeded, where it's difficult to say, um, it's difficult to know how much time you should invest in advance. Whereas on the other hand, there are projects that you're like, okay, there are few unknowns and we can make these concise. And so what I like to do, and I'd actually love your feedback on this, I'm getting some free data science consulting here
Yeah.
on air. But what I end up doing is I like to blend projects for my team. So and I'm lucky to have data scientists that all are capable of working independently and executing efficiently. So I can say, with those tasks that are relatively circumscribed, we're getting those kinds of things done all the time. But then I'm like, you know, spend your morning working on that. Let's make sure we're getting somewhere on that. But then spend the afternoon trying to get this big open-ended project off the ground. Let's understand that better and try to get it to a point where we can define a clear next step and express that clearly to management and say, you know, we have this big idea, it's going to take 2 weeks or a month of someone full time to explore this fully, in order to know whether there's something here. And then we'll be able to give you a better estimate after that on next steps. Anyway, so I've been talking for a really long time. It's your episode.
Yeah. No, I love the way you've kind of positioned that question, because as I've been listening to you, what it makes me think of is that there are probably a lot of data science teams that should picture almost like they're an internal consultancy. You know, uh, imagine that you're a consultancy like Pandata, for instance, right? You're inevitably going to have some non-billable time. It's just part of getting the job done. So it would be internal meetings, professional development. You're always just going to have some non-billable time. But if a consultancy was 90% non-billable, you've got problems. Okay. So I would think that if you're an internal data science team at a startup software company, all these different scenarios,
Mhm.
I don't want to rob. I mean, data scientists are creative people. That's why they went into data scientists. They like to explore and try new ideas, and they want the freedom to um, take a shot at something that maybe has a low probability of success, and they don't
Mhm.
want management looking over their shoulder like every second, right? In fact, that's
Mhm.
probably a good way to push a data scientist out the door if it was like way too structured.
Mhm.
But if those data scientists think of this kind of like billable and non-billable time, the projects that have non-ROI are analogous to billable time. And the projects that they really don't know if they're going to pan out, they're kind of exploratory, they're riskier. If they think that is non-billable time, and it's just like, hey, let's not let our non-billable time become the majority of our time, right? I mean,
Right.
there's a reason why Google came up with this 20% thing.
Right.
Then I think that alone kind of solves the problem, right? So I always like to say that predictive analytics teams should be self-funding. They should be profit centers, not cost centers. But I'm
Mm.
totally okay with 20% of their time not being profitable, because we need that time for employee satisfaction and to know what are we going to be doing 2 or 3 years from now. I
Mhm.
really think
Sure.
it's keeping into balance.
Yeah, and that's also where the breakthroughs come from. Like that 20% time, while it's short term is a cost center, it is where you could have a multiplicative effect in terms of profitability company wide if in that 20% time the data science team can come up with something that automates a big part of your platform or delivers a lot of value for your users.
Yeah. Um, if I'm not careful, I'm gonna misquote him, but I'm sure he'll understand. So a quick shout out to Ken G, who I'm sure everybody will be familiar with. I saw him give a keynote just about a year ago, and he was talking about keys to like data science success and so on. And
Is that at
one of the
ODSC
things.
East?
Oh,
At
no,
O
no, no, I don't.
No. He did a
Oh, it
keynote
could
at
have been.
ODSC East. Yeah. That was
It could
about a
have
year
even
ago.
been in London, maybe? No, no, it
Oh,
was in
yeah.
Boston. Yeah, ODSC
Yeah.
East. Yeah, no,
Yeah.
it probably was. Yep, yep. No, I remember. It was in Boston. But one of the things that he was saying was don't pressure the data scientists to always produce, ROI. I'm quite sure for the reasons that we just said, right? If you limit what they can do too much, you're not going to get one of the things that is most valuable about what they do. And we had speculated at some point we would have a conversation probably recorded specifically on this one issue. But that, when I said the gentle pushback that I sometimes hear, that's really it, right? We have to come up with a way of doing this where the data scientists feel free, yet nonetheless, they have to spend the majority of the time, maybe not 100%, but they have to spend the majority of the time on things that are known to produce value. Otherwise, you can't keep the lights on. So, in terms of how to know that a particular project is going to meet that criteria, for me, it's pretty simple. If you're going to make a prediction, this is going to sound, for some people, this is going to sound terribly old school, but I'm going to take this risk because I feel strongly about this. I think that generally speaking, we should be trying to predict yes/no questions. Not because we're always presented with yes/no questions by the business. I know that that's not the case. I'll give you an interesting healthcare example in a second. But because when we deploy it and we're trying to decide whether or not to intervene, that almost always comes in a yes/no form. So, for instance, take a classic use case like preventative maintenance. Almost invariably, you have to decide whether or not you're going to shut this thing down, inspect it, and verify that it needs maintenance. But this could be a wind turbine. This could be you're driving out to the middle of nowhere and climbing up those ladders, or you're sending a drone up maybe to verify it or something like that. Every time you have unscheduled maintenance, it's going to be expensive. So it's crazy to me not to do an estimate. So back to the healthcare example, and then I'll comment a little bit on how to make this estimate. So a healthcare example, a classic use case in healthcare analytics is 30-day readmit. Will a patient be readmitted on the same diagnostic code within 30 days? That's a simple yes/no question. And then if the answer is yes, they are likely to return with the same diagnosis, then you talk to the subject matter experts, medical doctors, among others, and say, how can we prevent this from happening? So it's a simple yes/no. I remember being asked by a data scientist that worked for a healthcare provider once, let's come up with a model that predicts the most likely next medical code that this patient will suffer from. So in that sense, it's like a next best offer or like Netflix and Amazon and so on, right? But let's just compare those two scenarios. What's your chance of being correct out of the gate with the 30-day readmit? Assuming the data's in balance or you force it to be in balance, something like 50-50, you get the idea. What about guessing which of 15,000 or 60,000? It depends on how granular you let it be about the diagnostic codes, you see. Also, what if you do know that diagnostic code and you've built such an amazing model that there's a 20% chance that you're right, which really would be remarkable if you're trying to predict which of 15,000 it is, and there's a 20% chance that you've nailed it, right? Mm-hmm. How does that help? What's the hospital do with that? It's not clear, right? I want clarity about what you're going to do with it. If I have clear instructions, I pretty much assume, and I know that not all data scientists would agree with me, but I pretty much assume if I have a clear mission statement, I can build the model. A lot of people will say, oh, you might not have the data, or the data might not be good enough, or it simply might not be capable of being predicted. Over the years, I haven't encountered those kinds of situations that often. If I have a clear mission statement, you know why I have faith that the model can be built? If it's core to the business, if it really is critical to the business, they're tracking it. And if they're tracking it, there's historical data. That's why. So something new or too exploratory or too obscure might not have the data to support it. Mm-hmm. But something that's core to the business almost always does, right? So I don't want to get into a lot of speculation about whether or not we can build the model. If we're choosing good projects, we can build the model. What I want to know is what they're going to use it for. I don't need to know the interface. I'm not trying to step on anybody's toes. If they're Agile fans, for instance, we're not trying to overthink the whole thing. We're just trying to figure out what yes/no question are we trying to predict and why that's useful. And that brings us to a confusion matrix. It's really that simple. So I say that somebody is going to come back within 30 days with the same disease. That's either a true positive or a false positive. And in 30 days, we will know which. And a subject matter expert at the hospital should be able to identify for me for each quadrant of the confusion matrix what the cost is. What if
Right.
we do the intervention and it wasn't needed? That has an exact dollar estimate associated with it, or a narrow range. What if we fail to prevent it and the 30-day readmit happens? Just look at the last 12 months of data and you have a darn good estimate of what that costs. So it's really as simple as trying to solve the problem, at least initially, with something that fits a confusion matrix, and then populating the confusion matrix with a financial estimate for each of the 4 outcomes. It's not rocket science.
This was awesome. That was so articulately explained, so clearly. And I had never thought of this before. This kind of your litmus test for a successful AI project is one that has a binary outcome that's key to the business. So therefore, historical data are inevitable. And yeah, anytime we have a binary outcome with a model, we can create that confusion matrix. And yeah, we can associate a financial cost with each of those 4 possible outcomes in the confusion matrix. I love that. That is such a clear system. It's so easy when we came into this topic, and I knew that I was going to be asking you about ROI. It's the kind of thing where I feel like people often give hand wavy answers, and you just gave a crystal clear one.
Well, and some people might say that that's been oversimplified to the point of being naive. So let's let that devil's advocate argument play for a second. Let's say they come back and say, well, that's lovely, Keith, but we really want to know why they're going to be a 30-day readmit. This almost gets us back to explainable AI, right? Maybe we want a reason code or something like that. I would say, well, fine. You've built your 30-day readmit. You can do a good value on that. If you already have that in place and your risk scores are accurate, then why not do something simple like K-nearest neighbors and find out what patient was most like patient Smith, and not just come up with one diagnostic code, but maybe the whole list of diagnostic codes that closest patient had. So you can, the point is, you're not going to derive value from the diagnostic code part, but it certainly can be a supplementary part of the solution. And I think you can see part of the problem is if you just go for the diagnostic code, it's never going to be accurate. It's not as clear how you can deploy it, right? But now what you could do is you could take a model that maybe has only a middling level of performance, but combined with an accurate risk score, hey, here's our best guess of the cluster of issues that is going to be presented this way. I remember I had a similar idea on a insurance fraud project where we built a really good model that gave a risk score on whether or not a particular claim was fraudulent. So that's where the value was going to come, because that's what had the intervention associated with it. Do we send the investigators out or not? But I said, well, let's just play around with a little bit of as projects end, and it's not always easy to renew them. The team's not available and so on. But we had this idea at the end, and I always wish we had followed through on this, where it would have been cool as an add-on to the project, say, what file that's already been investigated looks like this particular accident. It could even turn out to be the same criminal, right? These were staged accidents, so it was an organized crime thing that we were specifically looking for, right? But you can do that as a supplementary thing, or you could even do social network analysis. Go ahead and start with the binary, get your money back, which, by the way, for that project, I think was 30 mil or something. But get your money back. Well, I mean, like annually.
Yeah.
Right. So you've got your money back, you've got the goodwill. Now go ahead and supplement it with things like social network analysis, and maybe you can give the investigator a clue as to who might be behind this, because phone numbers are matching or something,
Mhm.
But you get the idea. You have to have the core to the project has to be something that's deployment friendly and that's going to produce value. It's not to imply that we're going to stop doing unsupervised and association roles and other things. It's just that if you lead with the binary, that's something that senior management's going to be able to understand, and it helps you come up with a budget and it helps you come up with a schedule.